following on from the previous video, I gave you this implicit equation here. And then if we want to find out the gradient at any point on this line here, let's say here, the bad way of doing it would be for us to rewrite this this implicit equation here into an explicit equation. So the bad way was in the previous video I showed you the bad way, which was us making y the subject in a way. So it was something like this: 2 minus x squared, and then so we would start with the implicit equation, turn it into an explicit equation, and then differentiate it from here. You see, it's very tedious this way. So now I'm going to show you a new technique. It's called implicit differentiation. So with implicit differentiation, you would start off with this. Okay, so you've got this thing here. So and here you've got one bubble equals another bubble. Now remember that when you have an equation, when one side equals another side, you can add equally, you can take away equally, you can times equally, you can divide equally, and you can also in one of the earlier videos I said you can take the you can differentiate equally. So you can actually do this as well. Okay, so starting from here, so remember, this here is just a new method of us differentiating this thing here. Okay, it's just a new method, implicit differentiation. So starting here, we're going to differentiate both sides. So that will take us to this. Okay, so we're going to differentiate both sides. So here you've got one bubble equals another bubble. Differentiate both sides, that will give you this. Now when you differentiate this thing here, so when you've got a plus in between, you can actually just differentiate this and then add it to the differential of this thing here. So once you're here, you can actually just concentrate on differentiating this thing and then differentiate this thing, and then later add the two together. Okay, so start out with this thing here. So differentiate both sides. That will that means you differentiating the whole bubble here. But then rather than differentiating the bubble, because there's a plus in between, you can just concentrate on differentiating this and then differentiating this. Okay, and then but here's the thing. So this bit here, you've got to differentiate y squared. But the thing is, when you differentiate y squared, now this here is just a technique. Okay, when you differentiate y squared, it becomes you've got to differentiate the y squared as normal, so it'd be 2y. But then you've got to times, so you've done that, and then you've got to times it with this thing here. Now this is a bit that confuses everyone. Now let's just look at this here. Here you've got y. Remember, y is a function of x. So that means you see when you differentiate x squared here, it just becomes 2x. But when you differentiate y squared, you've got to differentiate the y squared itself, and then you've got to times it with this thing here. And there's a reason for that. Remember that y is a function of x. Remember that y is a function of x, meaning that imagine you've got something like this here, 2x plus 3. So this here is like your y. Your y is a function of x. It means y is going to do something to the x. So you can imagine this bubble as a y. Now how would you suppose you've got this thing here, y? So this is like y squared. So imagine this bubble is y. When you differentiate this here, remember the chain rule. You would have to do this: 2 the bubble intact, which is pretty much y. Yeah. So you would differentiate it like this, and then yeah. So here this bubble here is y. When you differentiate this here, it becomes 2 the bubble itself, because this thing gets minus by 1, but we don't bother putting this 1 into here. Okay, so this here will be 2y, but then you've got to times it. Remember the chain rule. Let's start again. So y is a function of x. Imagine y is this. Imagine y is 2x plus 3, and then here we've got y squared. Okay, so that's like y squared here. When you differentiate this, you've got to use the chain rule. So you've got to do this: 2 and then the bubble it stays intact, and then we've got to times the differential of this thing here, which normally we would just do 2, but we can do dy by dx. Well, when you differentiate this, so basically you would differentiate it as normal, but then you got to stick in this dy by dx because y is a function of x. If you look at this here, x is really on its own. X is on its own. So when you differentiate it's pretty much you would just do the normal stuff. But here, because y is a function of x, it means you've got y is a combination. Well, y is like a bubble with lots of x's inside it. So when you differentiate it, you got to differentiate it as normal, and then you got to times the differential of the bubble, which is dy by dx. That's why you've got this dy by dx here. Okay, so this is a bit that really confuses everyone. If you don't understand it, don't worry. Just watch. I'm going to do lots more examples, so just watch it, and then after a while, hopefully you will understand it. But this is a bit that confuses everyone. So when you differentiate y squared, it really becomes, well, you would differentiate this bit as normal, which is 2y. Hang on. Which is 2y, and then you got to times dy by dx. And let me just repeat it one more time here. So here, if you differentiate this here, you would have 2 bubble, and then 1, but we don't bother putting the 1 in here. And then you got to times the differential of this. Well, I could just write dy by dx here because, well, normally we would just write 2, but I'm just going to write dy by dx. So the point here is that when you differentiate this here, you differentiate this bit as normal, which is this bit here. But because y is a function of x here, you've got to times dy by dx. Okay, so this bit then becomes this, and then now when you differentiate this, x is just x. It's not a function of anything else. X is just x. So that then becomes this. When you differentiate 2, it becomes this. Okay, so here the next step here is to take away 2x. So that will then give you this. And then here you've got one block multiplying with another block. You want to get dy by dx on its own. So you divide both sides by 2y. So that will then give you this. Okay, so from here you've got one block multiplying another block equals this block here. Divide both sides by 2y. That will then give you this. And then this block here remains on this side here. Okay, and then the 2's will cancel out, leaving you this. So dy by dx, this block here equals this thing here. And remember, this here is just a technique. I know it seems quite strange, but watch some. I'm going to do more examples. Watch a few more examples. After a while, hopefully you will get an idea. Okay, so after all that, dy by dx equals this thing here. You see, because so if you want to know the gradient, hang on, let me just summarize. We started out with a circle like this, and the equation was y squared plus x squared equals, what was it? 2 equals 2. Yeah, equals 2 here. We started out with this equation here. Now, our old method was to do it explicitly. This here was our old method. So this here was a positive version. This here is a negative version. And then this here is our implicit version. This here is our new technique here. So if you want to find out dy by dx at any point here, then all you need to know is x and y at a particular point. So for example, let's say you want to find out the gradient here. This point here is 1, the x would be 1, the y here would be 1. So the gradient here would be you putting this is your x here, put it into here. This here is your y, then you put it into here, and then that will give you your gradient. So the gradient at this point here would be minus 1 over 1, which is minus 1. And then if you look at this here, it does kind of make sense, because look, it's a negative gradient. Okay, if you want to find out, let's say this point here, you see, once you've got our new method here, this point here is minus 1, comma minus 1. So now this is your x, this is your y. X, put it into the x here. Y, put it into the y here, and then that will be positive 1 over negative 1. So that will equal negative 1. And then if you think about it, it does kind of make sense, because here the gradient is negative 1. Well, the gradient's negative, and it looks like a negative 1. Okay, let's say this point here. This point here is what? This point here is 1, comma, negative 1. So this is your x, put it into here. This is your y, put it into here. So this one here will become positive 1 divided by what? Hang on. Let me start again. Something's fishy here. Hang on, let me start again. If you want to find out the gradient at this point here, the x here is 1, the y here is negative 1. Okay, so if you put this into here, that would then give you minus 1. Okay, put this into the y here, that would give you minus 1. So minus 1 divided by minus 1 is 1. And then if you think about it, at this point here, the gradient does look, well, it's a positive gradient, and it does look like a 1. So once you've got this thing here, you can find out the gradient at any point on that line. But you see, the bad thing about about this method here is that you need the y and you need the x. If you look at this one here, if you want to work out the gradient at x here, let's say at 1 here, then all you need is x. You don't actually need the y. You just need the x. Put it into here, and then put it into here, and then you've got your gradient. Okay. If you want to find out, let's say minus 1 here, remember this is our negative version, which we've got to use this equation here. If you want to find out something at the top here, you've got to use this one here. But with our implicit method here, it doesn't matter. It works for the whole thing. But the downside is that you need 2 coordinates. Well, you need the x coordinate and the y coordinate in order to work out the gradient. But this one here, you just need the x, and then you can work out the gradient. But anyway, it doesn't matter if you don't understand this. Watch several more examples, and then after a while you get a gut feeling for it. Okay.